I'd like to take a look at a short trick when it comes to using modular arithmetic that might help you speed up some of your computations. And just again, have you become more familiar with this idea of trying to become familiar with adding and multiplying when you're not really doing the same adding and multiplying that you normally do. Okay, so let's take a look at some examples here. So if we want to solve this, 4 times 3 is congruent to x mod 2. Now, the trick that we're allowed to do, so well, I guess maybe the first thing that you would probably do is you would probably multiply this to be 4 times 3, and you would get 12, and then you figure out what is 12 congruent to mod 2. The trick that is nice with modular arithmetic is you could reduce these modulo 2 first. So to solve this, I could now state that this 4 times 3, reduce 3 mod 2, I get 0. Reduce 3 mod 2, I get 1. And so this is going to now be equivalent to 0 mod 2. So instead of multiplying this to get 12, we could now just reduce and then allow the smaller numbers to take place. Same thing here, if we're adding them together, I could say that this is the same thing as now 4 plus 3 is equivalent to 0 plus 1. Because 4 is equivalent to 0 mod 2, and 3 is equivalent to 1. The same thing over here, 4 is equivalent to 0, 3 is equivalent to 1. So this is going to be really nice to just say, yep, these are equal, these are equivalent to each other, these are also equivalent, and so this is now equivalent to 1 mod 2. As opposed to adding those to get 7 and then reducing that mod 2. Now, the reason that's really nice is when you start to work with gigantic numbers. So if I was to say, what is 25 times 158 mod 2? Well, if you take 25, you're like, well, okay, 25 times 152, well, that's a really big number. But reduce those mod 2, you just are multiplying 1 times 0, you get 0. So really nice and easy when you're working with really large numbers. And the same thing is going to be true now if the x is on the other side as well. So we could reduce these. So we have 4x is equivalent to 0 times x, which is equivalent to 0 mod 2. Now, notice x is allowed to be anything here, right? We didn't restrict x to be anything. We just simply had 0 times x. Well, we know that's always going to be 0. So what this says then is my solution in this case is that x is now equivalent to 0 mod 2 and x is equivalent to 1 mod 2. So both of these are solutions for us, and these are the only two possible solutions. Because remember, when we're looking at this mod 2, there's only going to be two classes, two of these equivalence classes. Those equivalent to 0 mod 2 and those equivalent to 1 mod 2. So we can use this trick as well to just help simplify things if we would like.